Hello friends, in our previous lecture we have completed the 10th chapter of accountancy and we have completed the first semester syllabus for accounts and statistics. So now today onwards we are going to start the portion for second semester of statistics, that is chapter number 5. Name of the chapter is skewness of a frequency distribution. Now friends, whenever we started the learning this statistics, first we learn how to collect the data or what is the data, how much types of data are there. Then we learn to present that data properly in second chapter. Then we have learned the measures of central tendency, that is mean, median, mode, quartiles, deciles, percentiles in chapter number 3. Finally we have learned measures of dispersion, that is range, quartile deviation, mean deviation. Okay, mean deviation we have not learned because that is excluded from the course. Coefficient of variation, all that things we have learned in fourth chapter. Now in exam till fourth chapter only will come, but still if we have time we have to start the next portion, that is fifth chapter, skewness. Now this skewness will depend on the previous two chapters formula, that is chapter number 3 and chapter number 4. So none of the formulas will be repeated here for you people. You have to remember the formulas by heart. So this is a type of revision also, because we will calculate here measures of central tendency plus we will calculate the measures of dispersion, so that it will be a small revision for you and our course also will be completed soon. So now we are starting with the skewness. Okay, what do you mean by actually skewness? It is somewhat a new topic for us, or it is based on scientific topic. Skewness is to learn the differences of the data or the trend of the data. How is the trend, or how is the data distributed, or how is the frequency of the data. Suppose a data is given starting from the lowest frequency going till high, again from the height going till lowest frequency, and having the differences same on both the sides, then that is called a symmetric data, because it is going, curve is going up and curve is coming down, as the curves you have learned in 10th standard also. So that is a symmetric data. And if the curve is elongated from its right tail or its left tail, then that is a skewed data. Now that skewness is positive or negative. So using the measures of central tendency, that is mean, median and mode, plus the measure of dispersion, that is standard deviation, we will learn here the skewness in the data. Okay. So on page number 171, measures of central tendency and dispersion have given important information about the population under study. The measures give the information about the values assumed by the units of population. Moreover, a comparison of two or more population and the analysis to obtain the other information is possible using these measures. We have studied the nature of population by these measures. The measure of central tendency and dispersion give us partial information of central tendency and dispersion of observations around the central tendency of raw data, but we cannot give the complete information. To get more information about the population is represented by a frequency curve, which I said. Thus, the direction, shape and form of a frequency curve can be studied using this frequency distribution. We will study the third important measure, that is called skewness, to obtain more information about the population. Let us understand the concept of symmetric frequency distribution before learning the skewness. As I said, if the curve is exact, then it is a symmetric data. And what is this symmetric data we are seeing here? A frequency distribution in which the observations of populations are evenly distributed on both the sides, equally distributed on both the sides, that is called a symmetric frequency distribution, and the curve is called a symmetric frequency curve. Underline the first sentence, this will be in the theory part. Generally, the frequency of symmetric distribution is found to be bell-shaped. Underline, its frequency distribution is bell-shaped. We shall study the concept. Okay. Here example is given, that is not required. We are seeing just its characteristics on page number 173. Following characteristics are generally observed for a symmetric frequency distribution. Which are they? Mean, median and mode have the same value. You have to know this thing, all the characteristics. Here mean, median and mode are same. First quartile Q1, third quartile Q3 are at equal distance from mean. Thus sorry, q3 minus m is equals to m minus q1. Why are they are taking q3 first and m at the end and then m at the first and q1 at the end? Because you know m is equals to second quartile, m is equals to q2. Now the highest value will be in q3, so q3 minus m. Next highest value will be in m, so m minus q1. So distance between the quartiles are also equal. Frequency curve is found to be bell shaped. Frequency of observation at equal distance on both the sides. The frequency distribution, I am reading the highlighted part, with lack of symmetry is called a skewed frequency distribution. The lack of symmetry is called skewness. Underline this highlighted part. So in a symmetric data, both sides will be equal. Now where both sides are not equal, that distribution is known as a skewed data and there is a lack of symmetry, because symmetry means curve is equal and lack of symmetry means curve is not equal, whether its left tail or its right tail is more elongated. Now what are the types of skewness? Positive skewness, negative skewness. So what is positive skewness? First sentence you underline. If the tail of frequency curve of a distribution is more elongated, sorry, right tail is more elongated, it is called a positively called frequency distribution. Again its characteristics will be given on page number 176. Upon negative skewness, its characteristics with figure are mentioned. Okay. The values of mean, median and mode are in decreasing order, means mean is having highest, then median, then mode. But in a symmetric data, all are equal. In positive skewness, they are in decreasing order, means the mean is highest. Okay. Then comparing to the distance of quartiles, in symmetric data they are equal and here they are in decreasing order. Distance between third quartile and median is more than the distance between median and first quartile. And here the right tail is elongated, there the tail is bell shaped. Then what is negative skewness? If the left tail of the curve is more elongated, it is called a negatively skewed distribution, and again its characteristics will be opposite to positive. In positive it is in decreasing order, so in negative it will be in increasing order. So you can see on page number 179, mean, median and mode are in increasing order, x bar less than m less than mo. Then distance between quartiles will also be there more. The distance between q3 and m is less than distance between first quartile and q1, and here the left tail is more elongated. Okay, so first we are writing about this thing, because we have to know in this theory part we are writing about this thing. So write the name of chapter. Chapter number 5, skewness of frequency distribution. Skewness of frequency distribution. Okay. Concept of symmetric, positively and negatively skewed data. So I will draw a figure which will explain these particulars. Symmetric data. Skewed data. Now in the skewed data, positively skewed data, negatively skewed data. Okay. Number 1. Figure of frequency curve. How is the figure of a symmetric data? It will be equal, so x bar is equals to m is equals to mo. Then here it will be q1, here it will be q3. You can see this figure on page number 173. This figure is given on 173. Again, the positively skewed data figure is given on 176. Right tail will be little bit elongated. X bar greater than m, greater than mo. Q3, Q1. Then here right tail x bar less than m less than m. So these are the figures of a frequency curve. In exam it will not be asked, but for your understanding we are writing. Okay, for small questions we need these things. Measures of central tendency. How will be the measures of central tendency here? Mean equals to median equals to mode. Mean is denoted by x bar is equals to median is equals to m. Here they will be decreasing order. Here they will be decreasing order. For denoting the decreasing order, we have to show the greater than. Mean, median and mode are in decreasing order. X bar greater than m, greater than m. Here mean, median and mode are in increasing order. X bar less than m less than mo. See, when it is decreasing it should be greater than, so it will be in decreasing order. When it is increasing this should be less and less than should be so. Okay. After that, distance of quartiles from median. Here quartiles are at equal distance. Q3 minus m is equals to m minus q1. distance between Q3 and M is more than M and Q. Q3 minus M greater than M minus Q. So here it would be distance between Q3 and M is less than M and Q1. So Q3 minus M less than M minus Q1. Then next, number 4, shape. Frequency curve is bell-shaped. Here we will write right tail of frequency curve is more elongated. Here we will write left tail of frequency curve is more elongated. So friends, these are all the characteristics about this thing. So you need to write it properly, which will help you to learn in the exam. Okay, so I have discussed all the important characteristics before you. The figure is not expected, I know, in the exam, but still you should know figure, measures of central tendency, distance from quartiles, and the shape. These 4 things you must know for this skewness. Only after that learning is possible. Okay, we are moving towards the next topic on page number 179. Concept of absolute and relative measure. We can find whether the skewness in a frequency distribution of population observations is positive or negative by drawing a curve, but degree of skewness in the distribution cannot be found using graph. 2 types of measures are used to measure skewness, underline absolute measure and relative measure. 2 types of measure are used to found the skewness, was absolute measure and relative measure. A measure of skewness which is expressed in same units of population is called absolute measure. It is denoted by SK. Underline, which can be denoted by the units of question, that is a absolute measure, and it is denoted by SK. SK means skewness. The absolute measure of skewness is obtained by difference between averages of Karl-Pearson's method and difference of Pauli's method. Methods, these measures cannot be used for comparing to population for different units. One is in rupees and one is in kg. So this absolute measure is not useful for comparison. Even when 2 populations have the same units, but it is not advisable to compare, and measure of dispersion may differ. So a relative measure is used for comparative study for 2 or more populations, which is called coefficient of skewness. Absolute measure of skewness of population is divided by measure of dispersion to obtain this measure which is free from units. So underline the first line. Relative measure used in comparative study for 2 or more population, which is called coefficient of skewness, and that only. And in short, relative measure is called coefficient of skewness, absolute measure is called skewness, relative measure is called coefficient of skewness. It is denoted by J. So below it you will write absolute measure of skewness is known as skewness only, is known as skewness and denoted by S and small k, denoted by SK, and in bracket we will write with units. The units which are given in question are used. relative measure of skewness is known as coefficient of skewness. What it is known? Coefficient of skewness, and denoted by small letter j, and in bracket you write free from units. No unit we will use after j. So this thing you write in your notebook, and after that now we are writing the formulas for Karl-Pearson. We have two methods, Karl-Pearson and Pauli. For 5.1 we will learn only Karl-Pearson. For 5.2 we will learn only Pauli's method. So now we are writing about Karl-Pearson's method. We will give the heading. Karl-Pearson's method for obtaining skewness and its coefficient. There are two types of formula. Type 1, when mod MO can be found for the data. Skewness Sk is equals to x bar minus MO. This is absolute measure. Then coefficient of skewness denoted by J, x bar minus MO by S. X bar minus MO by S. S is a standard deviation. Relative. Now friends, we cannot give the formulas for x bar, MO and S. This you have learned in previous chapter. Now no discussion about formulas is required. But yes, one thing I will say, when mode can be found, why we cannot find the mode sometimes? Because see, in a ungrouped data, when all the observations are one time or maximum repeated observation is more than one time, we cannot find the mode. For a discrete data, if the maximum frequency is more than one time, then also we cannot find the mode. And in continuous data, also maximum frequency is more than one time, or sometimes the classes are open-ended classes, or the classes are having unequal class length, or the data is a mixed data that is discrete continuous, we cannot find the mode. So when it is possible to find the mode, we will use this formula for skewness and coefficient of skewness. And if mode is not possible, then type 2. When mode MO cannot be found for the data, when mode MO cannot be found for the data. Then skewness SK is equals to 3 common x bar minus m absolute coefficient of skewness J, 3 common x bar minus m by s. Now what is this m? M is a median and this is a relative function. So for all the types of sums, first you need to check whether mode MO is possible or not possible. If it is possible, then only we will use the above formulas, and if it is not possible, then we will use the below formulas. Now a short discussion about the formulas. I am not writing the formulas, but we are discussing the formulas for mean. For a ungrouped data where there are only observations, formula for mean is sigma x by n. When it is a discrete data, sigma fx by n. When it is a continuous data, sigma fx by n, but in that x is mid values of each class. Whether it is inclusive class or exclusive class, it is not a problem. Okay. Then we will discuss about mode. For a row or ungrouped data, mode is the highest repeated observation. For discrete data, the value with maximum frequency, means maximum frequency is there and its x value will be the mode. And for continuous data, first we have to decide the class of mode that is known as a model class, and the class with highest frequency is called a model class. After that, the formula for mode will be MO is equals to L plus Fm minus F1 divided by 2Fm minus F1 minus F2 multiplied by C, where Fm is frequency of model class, F1 is frequency of previous class, and F2 is frequency of next class. So this was about the mode. Now about the median. For a row or discrete data, median is equals to value of n plus 1 by 2th observation. For a discrete data also, value of n plus 1 by 2th observation. And for a continuous data, first we have to decide the class. For deciding the class containing n by 2th observation, then we will find the median by m is equals to L plus n by 2 minus Cf upon f into C, where Cf is the cumulative frequency of previous class and f is the frequency of same class and C is the class length. Okay. So these were the formulas about median. Now lastly, the formulas about standard deviation. As we have learned in previous chapter, the standard deviation in 4th chapter, there were two types, where it is in point or it is in not a point or integer. That all other formulas you ignore. Which formulas we have used only the second time. Means I have written two types of formulas, this side and this side, but we are considering the formulas of that side. So for standard deviation, when it is a ungrouped data, formula will be S is equals to in square sigma x square by n minus x bar square. Everything is in the square root. For a discrete data, in square root sigma fx square by n minus x bar square, and for the continuous data also sigma fx square by n minus x bar square. So friends, we have discussed the formulas for x bar, mo, s and m. And also we have written the formulas for skewness and coefficient of skewness regarding Karl-Pearson's method, that when MO is possible and when MO is not possible. So today we have seen the total introduction of chapter. Now tomorrow onwards we are going to start exercise 5.1. Till that time, write all the things in your notebook and send to me as soon as possible. That's all for today. Thank you so much.